So yes, my name is Moshe Zadka, and as you see, this is what happens when things are interesting. They don't work. So today we're going to talk about boring and why it's better, because boring is better than interesting. So we're talking about boring object orientation. So Python started out with the everything is an object, right? Everything is an object in Python. Everybody knows that. That's a mantra. And that's just not just a mantra, right? The object model in Python is very close to the object model in Smalltalk. Not identical, but close enough. And Smalltalk were where a lot of these object-oriented principles were invented, right? So they really apply to Python much more directly than a lot of people think, right? They weren't invented originally in Java and C++, which have very different object models. They were invented originally for Smalltalk. So all these object-oriented design principles, like the least of substitution principles for those who know it, or the single responsibility principle, or the law of Demeter, all of these things were invented for a language which is very, very close to Python, right? So they should be applicable to Python. We should be able to use general object-oriented design principles for Python. So they do work. They apply to Python. But often they apply to Python in a way that's different than what you expect. And when people try to naively apply a lot of these principles to Python, they make their code a lot more interesting than it should and a lot more error-prone than it should. So we are still going to work with the classical object-oriented principles, and we're still going to work with patterns, but we're going to make our objects a lot more boring. So these are how you can make your objects more boring. These are the secrets that they don't want you to know. You can declare your interface explicitly. You want to simplify the initialization. You want to avoid mutation. You want to avoid hiding. You want to avoid methods. And you want to avoid inheritance. If you avoid all of these things, you will make your objects very, very boring, which is very, very good. So why should you declare interfaces? Well, the Zen of Python tells us explicit is better than implicit. But we keep having implicit interfaces, right? The most classic implicit interface in Python is the file-like interface, right? This function expects a file-like object. What is a file-like object? Does it have a .write method that should work? Well, like if you open it for writing, yes, but not if you open it for reading, right? So there's like a read file object. Okay, fine, a read file object. Does it have a .readlines? Does it have a .readline? Does it work as an iterator on the lines? What happens if you mix and match? If you do like read, is that supposed to work? And the million-dollar question, what is .seek supposed to do? Because like standard input doesn't have a seek, it fails, right? So maybe there should be a non-seekable, readable file that doesn't support lines or something like that, right? But people just say file, and they can get away with that because they're doing implicit. If they were doing explicit interfaces, they would list the methods that they expect. Right? This is great because you would know if your object has those methods, right? Once you're not allowed to be implicit, why do you have to say which method you expect? Once you declare your interfaces, you cannot wave your hand and say, maybe, right? Which is very dangerous, right? Because you're calling into this function and you're passing in a file-like object, which you're sure is file-like enough, and it currently works, and then someone maintains that method and says, I'm expecting a file-like object. Let's do .seek. Woohoo, yeah? Right, that's very interesting. Interesting is a way to get 4 AM pages. I do not like interesting. So one of my favorite ways to declare interfaces is with zope.interface, which I literally just had a discussion about it. It's kind of called Zope interface, and people are like, Zope, isn't that a weird old thing from like a long time ago? And much of Zope might be like, like not using like modern web programming, and some of it might be obsoleted by modern web. But Zope.interface doesn't have anything to do with Zope. In fact, you pip install Zope.interface. It doesn't bring the rest of Zope. And it is a really nice way to declare interfaces that has been proven in a big project like Zope, which needed interfaces because they had a lot of objects. So why do I like Zope interface that much? For one thing, that is one of the few things that allow me to introduce attributes the way I want to, right? And this is where I come back to Python is a little bit different than some of these other languages. In Python, we are not ashamed of using attributes as a public interface, right? We're like, this is an attribute. This is not a method. I do not want .get bounding box and .set bounding box and all these things. I want to have a variable .bounding box. And this allows me to say, that interface should have a variable bounding box, and then it should also have a method whether it intersects with a different box. Right? This is a very common way to do two-dimensional programming. It's not interesting at all what they do, but this is a reasonable way to say, here's what a sprite should look like. And now you know what a sprite should have, right? It should have a bounding box, and it should have a method that intersects, right? And you can even decorate these things with MyPy and say, that is supposed to be a member of this type that I didn't do because putting stuff on slide is complicated and doesn't have a lot of space. The nice thing is that you can test for it, right? Unit tests are great. Why not unit test for your interface? You already went through the trouble of declaring it. Make sprite is supposed to return something that is a sprite. Let's verify that. This will verify it has all the right attributes, it has all the right methods, and it thinks it's supposed to be a sprite, which is even nicer, right? This is a little bit different than some other languages, some other companies think are awesome, that kind of an implicit interface, right? Like, hey, looks like you're implementing these interfaces. It looks like you were trying to implement an interface, right? Like a clippy thing, right? No, this says, Sprite says, I want to implement iSprite, and because it wanted to implement iSprite, it should have a bounding box, and it should have an intersect method that should accept a box, right? This is great, because you can literally, run this, and you have a unit test that checks for types. This is awesome. Now, the next thing we're going to talk, after we're done talking about why interfaces will make your life more boring, is what is an interesting constructor? This is a very interesting constructor, right? It does a lot of stuff, right? So it creates a new object of type destination, right? And it opens a file. This is awesome, right? Because it's so interesting, so many things can go on, right? So the destination object, right? Now we have decided that this will always have a destination object. Now when we want for a unit test, right, assume that destination object, like is something that opens the web server or does something really, really interesting. We brought on all this interestingness right into ourselves, right? And now if we ever want to unit tests, we can't just bring something that looks like a destination. No. This decided it wants an actual destination. Now you have to start mocking and patching. And of course, these things never work correctly because it imported it from the other module, it imported it from the other module, and it didn't mock correctly. And now your unit test is opening a web server, and now all your tests are failing, and you don't know why. And your life becomes really interesting because, of course, the tests are failing at 4 a.m. And that's really interesting, right? And what can fail more than opening a file, right? Like this is like the classical, right? Like you have no permission, the file doesn't exist, the file exists, but only kind of, the hard disk is kind of, right? But it's decided it wants to open the file, and it will open the file. Even if it's on a network partition 5,000 miles away, it will open the file. It will hack the program for as long as it needs until it takes the file. And that's just to create the process. And the best thing is, and the best thing is that if it fails, what you have is an object of type stuff that has a dot destination, but does not have a dot input, right? Because if open failed, you will not get to the assignment method. Now you have a half initialized object in an exception, which means that object gets to be part of the frame stack. Now, here I, of course, did something unconscionable, which is I did not implement a wrapper method. Of course, I would never do that in production. I would write a wrapper method. The wrapper method would take f input, right? Because that's probably important for wrapper to know what file you've opened. Well, wrapper is going to take f input. What happens when we take an attribute that doesn't exist? Well, attribute error. Now you can't display your stack frame, right? You try to start your stack frame to Sentry. What you get is an attribute of f input and not why the file didn't open, which probably you kind of wanted to know. So this is bad, right? Like we all agree, this is going to make your life very, very interesting. You're going to have an interesting postmortem, right? Like, and in the postmortem, you'll describe the 5 steps you had to take to figure out why the file didn't open, because the alert from Sentry didn't show you that. That's not fun, right? What's fun is boring. This is a boring constructor. It does 2 things, which is it assigns the destination to the destination, it assigns the f input to the f input. Its failure modes are none. You cannot fail. If you have managed to call the constructor, it will run its course, right? Like there's like memory error, but like if you were in memory error land, your life is like done, right? So That's a boring constructor. But you had interesting code before, right? You had there was a reason you thought the destination really should be the destination object. There was a reason why you thought you really want to open the file with open system call and not have a string IO. There was a reason, right? You wanted to put that code. The best place to put that code is in what in other languages would be called class constructors, and in Python is just a class method, right? Class methods are a great place for class constructors because A, they have a name, right? So you can say from name, right? You describe what these class methods do, and it then creates a destination. It can open the file, and only once it has done those things will it try to create the object. The object will never start being created if something failed, right? If the destination call failed, you will not even try to open the file. Everything is fine, and you don't have a half initialized object. You just don't have an object. Not having an object is probably okay. You weren't going to have a really good object anyway. So we don't have a partial object. We have a great way to test, right? If you want to test, you just call the constructor with something that looks like a file. It would probably have been nice if I had like a strict interface of what I expect the file to be. And something that looks like a destination. And that's it. I don't have to mock. I don't have to patch. I just have to pass objects that kind of look like the object it was expected. Writing tests for that is a pleasure, right? So it's easy to write tests, and you will never have a partially initialized object, which will make your life a lot more boring. Now, you might think this is even too boring, right? Because all my constructors are going to look exactly the same. They're going to be def, under init, self, lots of stuff, self.stuff, that's kind of boring, right? You're going to fall asleep while writing your code. But you have a computer, and what computers are really, really good at is doing boring things, right? There's even a book called Automate the Boring Stuff with Python. That's what Atos does. It automates the boring stuff with Python, right? So instead of like having right, you have f input, and here I didn't bother declaring types. You really should declare that it's exactly what kind of file, and you have a destination, and this even writes the wrapper for you, which I forgot to do last time, which has been really interesting because then like all my stack traces would not show me anything about this object. Now my stack traces would actually show me useful stuff about the object, right? So this is nice, and I don't have to be that bored while I'm writing the code because Atos took care of automating the boring stuff for me. And this is great. And as long as I'm using Atos, I can even, with one small change, I can make my object immutable. Just saying frozen equals true. That's it. Right? I didn't have anything that like really needed to change where destination is pointing to or where f input is pointing to. Probably nobody would expect these things to change. This would be a weird thing to change. Right? In some objects, like you may have a counter that like makes sense to change. In this object, nothing like that makes sense to change. So I can still create the thing, but now I can't mutate the object after effect. Right? If I try to mutate it, I get a frozen instance error. This is great. Why is this great? Well, as we all know, sharing mutable data is the root of all evil. Now, some people try to solve it with sharing, right? Rust will really not let you share the object, right? Unless you kind of prove to it 5 times that you don't have the object anymore, so you cannot really share it. You can send it over there, but then it's gone here. In Python, it's really hard not to share. Everything is like all over the place, right? Like, you have a function, you can of course switch it to the function stack frame and grab everything from that, right? Like everything is sent all over the place, right? Threaded data is just woo, right? So it's much easier. Instead of stopping the sharing, stopping the mutation. Stopping the mutation is right here, right? I stop the mutation, it will never mutate. Well, it doesn't matter if I'm using a weird async framework with half threads that send the message between, like, it doesn't matter, right? It will get shared all over the place, but it will never mutate. This is much easier to solve. Like I said, literally 3 tokens in Python. Frozen equals true. That's it. It will never mutate, right? Not mutation is good, because now I don't really have to worry. Is something else holding it? Yeah, well, they can hold it. That's fine, because it's not mutating. So, like I said, immutability is a great bug avoidance strategy. And to kind of remind you of like the bug avoidance, this is a bug. Right? This is a classic bug that comes from mutation, right? Every time they call some function, right? Like the function will probably mutate the list at some point. This will cause a bug, right? Because you don't expect the list to be. Right? This is a classic, like, oh, I didn't realize some list was shared, right? Like I said, sharing in Python is really easy to do accidentally. Things are shared all over the place. You put it, it's shared. Right? There's no limits, right? So it's much easier. And immutability really simplifies your interfaces, right? A lot of time when we think of what our interfaces should be, we think, what invariants do we promise? And then we have to make sure that every method promises to not break the invariance, right? So if this attribute has to be less than this attribute, we have to make sure that every public method that changes this attribute will also change this attribute accordingly, or will fail in advance. If you have no variation, you don't have to maintain invariance. It was created the right way, it's going to stay the right way forever, right? So you have to check a lot less, right? When you code review method changes, you don't have to make sure you know all the invariants and check that every public method change has fixed all the invariants. No. All the invariants are there at construction time. You only have to check at construction time that the invariants are maintained, and everything until then is fine because the invariants can be broken. So it really simplifies your interfaces. You probably still want to create objects that are just like that object, but a little bit less, right? In others, that's called evolving, right? The nice thing about evolving is it uses only the public parts of your object, right? Evolve, all it does is it takes the object, it takes all the attributes, it sends them to the constructor other than the objects you have maintained, right? If you have any kind of constraints, verify them in the constructor or the validator. There's all kinds of ways to verify things with others. But evolve will give you what you need, right? So this is how I evolve my point to be like 1 point up, right? It still wants to be the same x, but updates the y, right? So it goes up one level. So you still have evolve. You still have the ability to pretend like you're modifying the object. But now if you send that, that will be a different object. Everybody who had a reference to the old object is fine. The old object is still there. It's going to be there forever until someone releases, and then it will get garbage collected. You don't have to worry about it. That's what Python is good at. Now, I want to talk to you about the other bad thing which people do, which is write private methods. Basically, there is never a good reason to write private methods. If you think, well, maybe the good reason is because I don't have to be that strict in under request, right? So you can see that I always call under request with a string, right? Now, if I made it into a public method, I would probably have to be very careful to say, always call it with a string, never call it with a byte string. If you call it with a byte string, really bad things will happen to you. I don't have to do that, right? Because I have that. It's an underscore method. I don't have to define that. And I have .get and .set and .get and .head, and everything looks fine. But you have given yourself too many permissions, right? You have given yourself the permission to not carefully say what request accepts, right? And the reason this is dangerous is because you're probably not the last person to modify this code. As you can see, this code is missing put, right? And probably post, and probably 5 other HTTP methods are important. There will be a maintenance programmer somewhere down the line who will add another request call. So your permission not to be very, very careful means that that programmer is not going to be very careful about not sending a byte string, and might send a byte string, and now everything that you were afraid of happening. The reason you made requests internal, the reason you made requests private is you didn't want to be careful about these things. Well, you still had to be careful about these things, right? Making it private didn't solve any problem. You still had to document. Now, I'm not saying that whenever you have a method, you should make it a part of the public interface. I'm saying there's a correct way to not make it a part of the public interface, which is make it a public method on a private object. And this is almost a mechanical refactor, right? I have raw HTTP session. I have a request. Now, that class can go in a private module, right? So you don't have to make it as part of your public interface as far as the module. But now that you made it a part, even though it's an internal module, now you understand that that class deserves documentation. The people who maintain this probably need to know that what request assumes, right? Request assumes that it will get method, right? And then HTTP session has a private variable called _raw, right? Private variables are fine, right? Just private methods are not great. And then you can call get, and it will call get on underscore, and it will call request on _raw, and so on. And this means you have, and if you do that, right, like this was a very simple object, right? Because it didn't have a lot of attributes, because I tried to fit on a slide. In real life, what will happen almost always when you say, okay, these private methods, what private object really should they be a method of, you'll find that you don't need to copy all the attributes over. There'll actually be a coherent sub-object hiding behind. And almost always, when you write a private method, there is actually a coherent private object hiding behind those methods. And if you just follow that rule of like, move over all the private stuff, all the private methods as public methods of a, then ask yourself, okay, which attributes do I actually need to move over? It will usually be a strict subset of the object, and it will cause good pressure in your code, right? Often, the reason you have this many private methods is you're making a God object, and you should probably break it up anyway. Well, now that we've done with private methods, the question is, do we need public methods? And the answer is often not, right? So the reason we think we need public methods is this is a classic case, right? Like I have points, and I don't really want to have to care about whether it's a 2D point or 3D point. I just want to call distance from origin and get the Pythagorean distance from origin, right? So this is a 2D point. This is a 3D point. And as you noticed, right, by the limitation of making a presentation, I couldn't fit both classes on the same slide because like there was code in the logic, right? And these are pretty simple classes, right? Like at some point, someone will want the New York City block distance, right? The sum of the absolute value. Someone will want the max distance. Someone will want the general P distance, right? And maybe other things that you can do with points that have nothing to do with distance. This will bloat your objects more and more, right? They will no longer fit on a slide, but they might not longer fit like in like a reasonable screen full, and eventually like you'll have to scroll down and down and down, and that's not fun for anyone, right? You have bloated interfaces. And the only reason you had these bloated interfaces is because you want to make sure that you did not have to care whether it's a 2D point or a 3D point. You wanted the dispatch to happen automatically. Well, what if you can make the dispatch happen automatically without putting gazillions of methods in our objects? So if you look, when I decided to make it a single dispatch example, I can actually fit both classes into one slide because they have no logic. Right, these are great classes because you understand what they do, which is nothing, right? One class is x and y, it doesn't mutate. The other class is x and y and z, it doesn't mutate, they're all floats. Really simple to understand what these classes do, which is nothing. They represent points in 2D and 3-dimensional space. Now, you want to think about distance. You think about, you know, like maybe this is a separate module, right, which is called the Pythagorean distance module, right? And in that module, I have a distance from origin. Well, if I don't know anything about the point, I probably should just mark it as not implemented, right? I don't know how many dimensions it has. Maybe for the Hilbert space one, I'll need custom code, whatever. And then I register custom code for point 2D. I register custom code for point 3D. You can verify that this is the correct code. And now I can call distance from origin on both 2D points and 3D points, and it will just call the right one according to the class. But I have separated the concerns. One module has just the different kind of points I have, right? And it's over there. And the Pythagorean distance module can be in a separate PyPI package. Right, again, that might not be interesting for things that are points and just like one kind of distance. But imagine that, like, you might want the different metrics, right? The maximum metrics. You might not have known that you needed it when you wrote the class initially, and someone else wanted to write the max. They could put it in a separate PyPI package, registers as this single dispatch, and it just works, right? So you can literally add the equivalent of methods, by which I mean things that follow the 1 minute left. Wow. Okay. I'm going to switch that because this is a complicated topic. And I'm going to talk about composition. No, I'm not going to talk about composition because I think this is also a complicated topic. And I'm going to go to like the summary. So you can do anything you want in Python, right? Python lets you get away with everything, right? Single inheritance with overridable constructor, mandatory interface, sure, whatever, you can do whatever you want. And the problem is, a lot of the big systems in Python were written by people who did not know how to write big systems when they started. So what people do is they look at a big system that is considered like a pretty well-written system by good people, Twisted, Mercurial, Zope, a lot of these big systems, right? Like people take inspiration from them, Jupyter, right? A lot of these systems are written by great people who did not know how to write big systems when they started. if you take lessons from these big systems, you're taking exactly the wrong lessons. You're taking people at the worst, after they have kind of realized that they made mistakes, but they are now bound to those mistakes by 15 years of backwards compatibility, and you're taking that lesson, you're now becoming a part of your problem, right? Your system, if you're a good engineer and it becomes popular, will now inspire other generations, and by that point, you'll be 15 years along, and you'll be like, oh, wow, that was a mistake, but it's too late to fix. So this is a classical case where we tell you explicitly, do as we say, not as we do. We have learned these lessons, right? Like a lot of these lessons were learned by the team who wrote Twisted. I talk a lot with the people who wrote Mercurial, right? Like if you look at the talks by them, they say almost the same thing. Do as we say. Do not copy the lessons from our systems. Those are bad lessons to copy. We realize we're all, I like to think, pretty good engineers. We have regretted those mistakes. Those are all mistakes. You should not follow them. If you have a big system, you're going to have a big headaches. You want to make your objects boring. Write less interesting code. Be as dumb as possible when you're writing it, because you're going to need to be a lot smarter when you're debugging it and when you're getting paged at 4 a.m. Thank you very much. I'm Moshe Zatkai. This one I talk about boring object orientation. I don't think I have...
So I thought it was pretty interesting how you showed to register to kind of decide the mapping for the method. But I was wondering if there is overhead in your example there. I know in Python we're not always concerned with overhead, but...
So it's true. There is more overhead. Again, as everybody knows, premature optimization is the root of all evil. That's probably not going to be where your bottleneck is. If your bottleneck ends up being in the time it takes to call the distance method, you're probably anyway doing something wrong, but at that point you can move it into being a method, right? It's a pretty straightforward refactor. You probably want to do it when this becomes a performance thing, rather than at the point where you do it for all the methods and then you put like 50 million methods in your object. You don't know which method is going to be the bottleneck. Cool. I think I have time for maybe one more. How many more questions?
We give you 3 more minutes because
Okay, I think like maybe 1 or 2 more minutes. Two questions, okay. So maybe one question, then one after that. Okay, yeah, go on.
Okay, so question. So I ran into an issue at work where I have an object that takes as arguments strings, and it has to convert those strings into dates. They're all dates, but they're sent to me as a string.
Yeah.
Where does that take place?
So that definitely takes place in a named constructor called fromStrings, and the object should just take dates. This will allow you to slowly refactor, hopefully, your code to call more and more into the constructor with dates and less to the weird date string parsing. Cool. So I think I have time for one more. Okay, but I don't think I need it. Okay, cool. Thank you all very much.